All right, so I'm Mark McGinley, and I'm from the science unit here at Lingnan. I've just completed my second academic year at Lingnan after teaching 25 years in USA. And I thought Paul did an excellent introduction into sort of how this started, and I also share his surprise and amazement that there are so many people here listening to this. I really thought we would be talking to the six of us who met last time, so I hope this is useful. So I'm from America, and when you get a report card in America, you get a grade. And next to an A, it says excellent. Next to B, it traditionally says good. What it says next to C is variable depending on where you are. Often it says average, but it rarely means average. And so when I think of a C grade in the American system, I think you have an adequate mastery of the material, acceptable mastery of the material. A D grade would mean a poor mastery, and a failing grade would mean fail to achieve enough mastery. So the grades as they're assigned in the US are supposed to be measuring your mastery of the material. And traditionally the way that it works, and it's definitely the way it worked at Texas Tech University, where I just was for 24 years, is that 90 scores of 90 and above were an A, 80 to 90 was the B range, 70 to 79 C, etc. And so that's been the way that I've taught throughout my entire life. I don't think that's the way I was reared as a student. I think in a student, I was in cases where there was some curving going on, which is rather confusing. But once I got to Texas Tech University, where everyone else was assigning grades in this manner, I sort of switched to following that because it just stopped the students from being so upset all the time. But what was intriguing when we were having this discussion before, if I tell a student they got 70 in my course, that's an indication that they're on the poor acceptable borderline. When Paul tells them they got 70, he does it with a large smile on his face. And that told me then that perhaps we need to be communicating much more. I don't think it matters what we do. But the important thing is that we can explain it to the students and that they know where they're coming from. So I'm dealing with Paul's problems in, I think, similar ways. And so I'm going to talk today about a course I teach, Natural Disasters, Science, and Society. This course is part of it's now called Science, Technology, Mathematics, and Society cluster of the core curriculum. The idea is to introduce students to the process of science, talk about a particular field of science, generally earth science and atmospheric science that relates to natural disasters, and then talk about how those natural disasters affect society. And the way that I assign grades in these courses is 40% of their grades are based on quizzes. Throughout the term, there are 3 quizzes. There is class participation and writing assignment, which counts for 20%. There's a term paper they turn in at the end worth 15%. And then there's also what I call the final quiz that I give in class on the last day that counts for 1/4 of their grade. And maybe because I'm a scientist, so business, you can still use numbers, but because I'm a scientist, I deal with numbers. And also there's the problem of you often get numbers in the way that scientists assign grades. So my problem is I need to get numbers, which I will then reconvert into grades. So I'm going to talk about how I try to do that did that in this class. So I'd heard of rubrics. I came to Lingnan and suddenly the rubrics were what we had to do. And of course, I'm an old dog. I resent being taught any new trick. But what I did learn very, very quickly is that especially teaching science, which is an unfamiliar topic, and teaching in English, which is an unfamiliar language to the students, that having very, very clear expectations of what I wanted the students to do actually made great sense here. And when Jim started showing us rubrics, I saw, oh, okay, this is not crazy. This, in fact, makes good sense. And so I have found, though, that so I do have a rubric that's been approved. And it's been approved, so you can't undo it. It's been approved for use in exams, right? But in reality, different exam questions need to be graded in different ways. And so as a scientist, I might ask them to draw the graph that shows this. And you would get so many points for this axis, so many points for that axis. You can't go through and have an individual rubric for each of those things. But in general, we all know that you get higher scores for giving correct answer, giving more information, and organizing it more clearly. And hopefully that pops up in a rubric like this. So in the course of my term, I had 3 quizzes. I found the first time I taught this class, students bombed the first exam terribly, and that was clear they didn't have any idea of what was expected. So what I do now is I have what's called a mini quiz, where I just give them one representative test question and get that back to them before we have the big test. Then throughout the course of the term, there are 2 tests. Each of these are worth 50 points. And I choose 50 because that's cleverly half of 100. And it's easy for me in my math to realize 45 equals 90. And so, so for each of these quizzes then, I would grade them. And it did work out this term that the results of all of these quizzes, I would have considered 90% to be an A. So I told the students, on the first quiz, if you scored over 45 points, I would consider that an A on this test. If you score between 40 and 44, that would be a B, et cetera, et cetera. So after each quiz, the students got the feedback about where they stood. Putting in sort of a further explanation of how to calculate what they should do in the future, how it all works together to fix their grades makes great sense, and I will add that in later. So at least during the quizzes, the students knew where they stood. And then what I tried to do is to calculate then their overall proportion of quiz questions they got right. Slightly modified, and you don't care about that. So out of their final quiz points, they got 100 points for that. And I would consider if they got over 90, that was excellent. 80, 90, that was good, etc. Then the participation is a little more tricky. I turned that into a number. Between 0 and 100. And basically, by combining there was a writing assignment and class participation. That's also a scale from 0 to 100. Now I get to the final paper, which is where I sort of followed on some of the advice that Paul gave when he was talking about this earlier. So the final paper is they must choose a specific natural disaster. So they can choose the Sichuan earthquake, they can choose the tsunami that occurred off the coast of Indonesia, and then what they have to do is to explain this to non-scientists about the scientific cause of the earthquake, of the disaster, how the disaster affected the community, and what we learned about how to minimize the effects of these events. And then what I tell them is, on the rubric, is the science part counts for 35%, the society parts counts for 35%, being able to communicate, including communicating effectively in English, counts for 25%, and just listing the sources. Because they are writing a paper as they would to their peers, if you were explaining this to your peers, you would not footnote it or that. But I wanted them to still show me their list of references. And so then what I have then is a rubric that has how I assign grades for each of these rubrics. And I first saw about rubrics using the American Association of Colleges and University rubrics that kind of follow this format. So basically, there are 3 categories. There is the benchmark that students are supposed to do. There's exceeding the benchmark, or there's failing to reach the benchmark. And what I did when I graded this class last year is for each, and so I have the similar thing for each section. So here's the 3 benchmarks for science and society. These are not so brilliant that you need to read them. For communication skills, also for the appropriate use of resources. What I did last year was for each of these categories, I said, are they falling in category 0, category 1, or category 2? And of course, category 1, being sort of acceptable, was a broad range. So then I gave them 1 minus, 1 check, 1 plus. and work through the grades. What I've done this year is I've realized, why worry about ones and twos? Why not do things that students completely understood? So what I would do then is, I agree with you the way you divided it out. I would say that I would consider good work, its seating standards would be B+ and above. The standards would be the C range, and poor would be less than that. So for a student 1, I would just say that they got a B+ score on their science portion of their paper, a B+ on the society proportion of their paper. Their overall communication was in B. They did a good job providing their references, and I have these numbers for these letters for each student. And what I need to do is to turn them into an overall letter. And what I do is the intervening step of turning it into a number first. And I go back to my 90, 80, 60 American roots. So what I said is, if you got an A on that section, I'll consider you a 95, an A- 92, etc. And so on each of the 4 sections, they get a number, and I calculate the weighted average. So this first student got a B+ on the science, B+ on society, B on communication, A on references. To calculate their final score, I would say 88 times 0.35, because that's what counts for that part, plus the second score was 88 times 0.35. I think they got a B, 80 times 0.25, 90 times 0.05, and I add that together, and you should get a number between 0 and 100. And you just put that in a simple little Excel spreadsheet, which I can do because I only have 35 students. Would I be as patient with this with several hundred? Probably not. And so then I get a final grade on the papers. But the students can learn each section, how they did on each section. So then what I do is take the weighted average of the quizzes, participation, final quiz, and which was graded out of 100 points, and their paper. And I again do a weighted average, so I get a number again between 0 and 100. And then you have to decide where to draw the dividing lines. And as I had been using sort of the 90, 80, 70 sort of notion all the way through, I continue to do that. But what I often find in a course like this, in the non-majors sort of course, that sometimes I'm willing to drop the lowest C down a little bit, because there's those students that perform horribly on the first couple of exercises. They figure it out. They improve to where they're at least getting solid C's or better on the final exam and the final paper, and I would hate to fail them. So in this course, I put C- down in this level. And I still haven't exactly decided about adding pluses and minuses, because at my university in the US, pluses and minuses didn't matter. They didn't affect GPA any, so adding them tended to annoy people. If I got a B+, then why didn't I get an A? And if they got a B-, then why did you give me a minus? And so here they do count into GPA, and so I'm still figuring out exactly how I want to deal with those. So that's how I try to put my things together, which is fairly similar to what Paul has been doing. And what it takes to make this work out right. Right? So there's nothing magical about 90%. In Texas, there was. 90% to them was a magical number. Clearly here, there's nothing magical about this number. I could decide if you're higher than 87.2, you get an A. But to sort of have this sort of consistency, I'm going to try to stick to this scale. And so when you're grading a paper or grading an assignment, you have control of what grade you give. And so you have control of where the lines fall. The problem becomes more problematic when you write exams, because you can't always assure that a student with an excellent knowledge will get over 90 on the exam. And I realize that what you have to do, if you're doing this kind of approach, is you have to think carefully about how you write your exam questions. So you need to have many, many questions, right? So if a person who gets a 75 has what you consider an adequate adequate understanding of material, there needs to be lots of points that people with that level of understanding can have. And so often, and particularly in my class where they're trying to understand complicated scientific processes, the major exam questions I ask are not anything confusing and tricky. They're just saying, can you meet the intended learning outcomes? Describe how this kind of plate tectonics affects a volcano. And so you would expect then students that are following along in class will be able to give an acceptable answer for that. And then you can have a few questions that try to separate the average from the good, and a couple of questions that try to separate the good from the excellent. And so I sort of realized, without ever explicitly thinking about it, that's been how I've been designing tests throughout most of my career. And so you try to think, these are questions that I expect everyone to be able to do well on. These are questions that are going to separate a little, and these are questions that are going to separate the final bunch. And so I think the alternative way of doing is to give very difficult questions and then allow there to be a much greater amount of spread. And so I don't think that my way of testing in this class does not do a very good job of separating out the high end. But in reality, I'm not worried about I mean, this is a general education course. If a student has an excellent level of understanding, it doesn't matter that the other person's level of understanding was even more excellent. So I didn't worry about doing them out very much. So you do have to think about, if you're going to work my system, you have to think a little bit about writing your exams in a way that would cause the answers to spread out right. And part of the difficulty I'm having here at Lingnan is there's a difference in the student population than I was familiar with at Texas Tech University. Texas Tech University was a state university in Texas. We had some of the very best students in the state. I think we have a higher high at Texas Tech than you have at Lingnan, but we also went down to about the top half of the high school graduating class. So we had many students that were not very good. And so what I worry here is, am I properly recognizing this is excellent work, this is good work, this is average work? I can talk about that with my science teaching colleague, Professor Fong, who's now doing research in Thailand, but he's also American, and so we come from kind of a similar background. And so I think it's important, it doesn't matter how we calculate grades, but that there's a level, if A means excellent, as opposed to top 15%, then there needs to be some way that we're near the same page on excellence. And I think that's a continuing battle. And just as a aside is, I think we can use this for assessment. So one of the things we've been worried about in the science unit is how are we going to assess the core curriculum level, cluster level intended learning outcomes. And one of the things that we're trying is to say, we have a benchmark that says they need to be able to discuss critical issues of science. Well, I can look at the grades I give a student on this part of the test and count up, if I consider B plus or above to be above the benchmark, I can count how many are meet the benchmark, exceed it. So by doing this grading in the very simple way that Paul has expressed it, and next year I will make a sheet, put that on and just do the circling. What a brilliant way to do it. Then that makes it very easy to do this sort of assessment material that's going to be important for these quality assurance things in the future. So I certainly don't claim to have the answer on how to do this, but going through this exercise has forced me to think more explicitly about how we do this. And I know I can do a better job, I need to do a better job of letting the students know how all this is going to translate. Because I had 2 students last year do grade complaints, and both of those ended up with a score of 80.5, so they got a B. So they were on the very, very low end of the B range, and I certainly don't think they were complaining about getting grades that were too high. So it was not at all clear to me how they could have had any anticipation that their grade ever would have ended up into an A. So I really like your, giving them the little formula. You plug this grade in, you plug that grade in, anticipate what your future grades are and need to be, then there should be no surprises. And generally with the 90, 80, 70, 60 line, I feel comfortable if I want to drop it. I've never in my life raised it. So I would never say if you're getting 90s all the way through, and when I get to the final exam, deciding final course grades, say you have to have a 93 or above, then I've been giving the students bad information. And so I can always be more lenient at the end, because then they're surprised in a positive way and not a negative way. So again, I'm happy to get any great feedback and look forward to the discussion we have. So thank you very much.